Alright, so if you don't have any questions on the previous topics that we discussed, so we will continue with today's topic. We'll go to the subsequent transformations like row generation, SQL, validation, map operation, and then we will go to a combination of XML transformations that are present. Alright, so let us start with row generation transformation. So there are two things in data services which are with a very similar name. One is row generation transformation, and the other one is a function which is generate row number. Right, so the reason why I'm bringing up these two together is like sometimes to confuse you, or to understand if you know the complete details of the tool properly, you might be asked about these difference between these two transformations, or what is the difference between row generation and generate row number, or we also have something called generate row number by group by. So these two are functions, generate row number and generate row number by group by. These two are functions in data services using which you can do either a row number generation or group by in a particular column and generate how many records are present there within that bundle. Or generate row number is a transformation. Sorry, row generation is a transformation. So this transformation actually helps you to build your templates, right? So especially when you are working on any project, and let us say that your staging table or some lookup table has a structure, and this table has to be built in this way that it should have a serial number, name, then target name, timestamp, and text. So let us say if we have a table like this, right, and we know the table structure because of our mapping sheets and everything, we know the table structure, but this table is not present in your environment, right? Still you are in development phase of the project and this table is not present in your environment. And if you want to create one, though your though your data owners or your source system doesn't have this table, they can just provide you, let us say they will tell you that, okay, this is how this table is going to be, and you can proceed with your structures. Later we will try to populate some data into it. So if in case you want to create an empty structure like this, you can utilize the row generation transformation. So let us go ahead and look at the description. It says generate a column filled with integer values starting at 0 and incremented by the end of the values you specify. So there are two ways in which we can use it. Way 1, let me just utilize it. So job underscore row generation, then df underscore row generation, and if you select this transformation, drag and drop it into your data flow, this is a source transformation, which means it is not having a connector on the left hand side, but it is having a connector only on the right hand side, which means it acts like your source. It is not like the intermediate transformations like case, merge, or query that you have seen so far. This is a source transformation, right? And this one, in the scenario 1, if you want to create an empty structure so that you can utilize that in your job and continue building your job rather than waiting for somebody to provide you the table, so you can use this whenever there is no source table present. You can use this row generation transformation as your source, and you can go and create your structures. New output column, then sales order, then quantity, type as varchar, so I'm giving it as 10. So I want to create this structure. This is one of the table structure that is needed for my job, but this is not available in an environment. So anything that is present on the schema out should be mapped. If not from the direct source, it should be hard-coded to null. So since it is an integer, I should not pass two single quotes here, but I can pass null, right? And for the next one, I can pass null. And here for this one, since it is a varchar, I can just pass two single quotes. So I'm trying to, create a structure, map it with some null values, and load it into, or create a DML statement in your target data store. And you go ahead and validate this one. No errors found. Now select your job, right click and execute it. So this will go and create an empty structure. So without this row generation transformation, though you use any other transformation or any other, unless and until you have a table, you cannot go ahead and build a structure, right? So if you use any other transformation just in case to showcase that it is a source, you will end up failing the job, right? So now this is created with one record, and if you go ahead and look at the table, this table structure is created with sales order number, quantity and type, right? And initially a null or a blank record is passed on to the table. Now you can go and utilize this job and start building your job, because data services always deals with the metadata, and only at the time of execution you need the real data to flow in, right? Till that time you don't need the real data to flow into your system. So for you to complete your job, yeah, definitely you have to go ahead and work with the metadata. So this is business case one. So this is one of the most important thing that you see on the right side corner of the window. So this is annotations, not the corner but on the right side. So if you click on this, you can give some descriptions to your code, right? So it is just like some comments that you can keep on the code so that anybody can open this and look at this and they will understand what you are trying to do, right? So this is case one. So the case 2 scenario in which we will be using this row generation is if you are trying to call some functions, right, which we will look at a little later when we are calling a function, because when you are calling a function is not a part of your table, right? You will not have any table for you to hold a function in it. Your table holds the data, and one second, yeah. So your table holds the data and your functions are present on your system in a separate pattern, and if you want to call those functions and work on it, right, so you will not have a specific source. You have to just call it from nowhere, right? So in those cases, what you need to do is you need to use the row generation. We have a live scenario for that. We'll look at that a little later. And the third case is if you are trying to, this is one scenario that you generally don't use, but I'm just letting you know how this works. So I'm using a row generation transformation as a combination with a source table. And let us say I remove these columns. Add some of the columns to the map to output, and then from row generation there is a default column called row ID. You get it to the schema out, just put it at the last, say insert below. Right, so you're not joining anything because row generation is just only one column. Yeah, there's no need for you to join. You'll not even find any errors. When you run this job, this is case 2. When you run this job, there will be a row ID, di row ID created at the end of your table, which has a constant value as 1. Right, so it starts with 0. So for the entire table, for entire 830 records, if we go and see, right, it gave a value 0 to that one. So if you want to cross check the data, just right click and say add to filter and say is not equal to 0, apply and OK. You will not get any records. Right, so that is how this row generation works. It creates a new output column. Right, if you click on the row generation, you can open that. It's a row number starts at 0. Now you can convert that to 1, and row count is 1. Right, and you re-execute the job. It will create a new output column with a value 1 to it for the entire record set. So if you go and change this, let's go and look at the data. Right, so entire column is filled with a single value is called as 1.
Yeah, Rakesh.
Yeah.
But we selected incremental by 1, right? But it is giving constant value for every record.
Yeah, that is because you are saying the row number starts with 1. So if I give the row count as 2, right, so this will go and change. This will not change any value, but now look at the count of the records in this table. It has 830 records. Right, so it says, I think this is one more error. A primary key constraint, right, PK violation, which says that you are trying to insert a record one more time into a column which is a primary key. So if you get that error, so if it is relevant, uncheck the primary key, or if it is mandatory that you need to maintain a primary key on the table, you go and check your data. Right, so I'll just show you what exactly happens when we select this to 2 and run the job. You will see double the volume of data. So let me just refresh this. So go to the profile tab and click on records. It is 1660, which is double of 830. And if you go and look at the data, you'll have row ID 1. And if you apply filter on that, you'll get 830 records with row ID 1. And if you want to modify that filter and say row ID is equal to 2, refresh this, and you'll have another 830 records where the row ID is equal to 2. It's just showing the values that are present in page 1, right? So that's the reason why it is showing 170. But if you go to the backend database and write a query saying that select this thing, which means this row ID, as you set the increment by 2, it creates 2 sets of data, right? So one case where you can use this is like if you want to apply 2 different business rules on the data and go ahead and validate how it works, or you want to go and see how this thing works. So you can create 2 sets on this one. Sorry,
but it should give row IDs like 1, 2, 3, 4, 5 for each record. It should.
I'll get to that. So that is what we see from the row generation, because this is generate row number transformation. row generation transformation. The other one that we'll be talking about is row generation function. Yeah, so that we will look at a little later. I'll
It's
get to
okay.
that.
Row generation means what is this exactly?
Yeah, so this is a transformation, and this generates a single row in the target table. And when you don't have any source table, you will be using this transformation to build your templates. This is not useful, but it is good to know about it. So it
So
is
like
not a row generation, which means it will create an incremental value like 1, 2, 3, 4, 5. It is not like that.
for empty structures we can use for second scenario it's like it's not at all useful, right?
It is useful when you want to apply two different rules. Let us say in there is some discount thing, and you want to do a forecast analysis on your entire data set, saying that if you give a 5% discount, what is the output, and if you give a 10% discount, what is the output on the entire data set, right? Well, how will you do that on a single data set? You have to run your job twice, right? So instead of doing that, you can use two query transformations here. And in the where condition of first query transformation, you will say where di row id is equal to 1, and in the second one you will say di row id is equal to 2, which
How
means
can
you are splitting a single data set into two. I mean, you are splitting that into two data sets, and you are trying to apply two different set of rules on that same data.
if we use one and increment by two, system is automatically assigning one is for separate group and two is for separate group, right?
Yes.
How can it decide system?
Sorry?
How can it split the values?
Okay. So now you've done this, right? So now you use a query transformation. Call it qt_1. In the where condition, go and say where row id is equal to 1. Now what will happen out of those 1660 records? 830 records has row id as 1. So it will capture all those 830 records and put it here. Now you can apply one different business rule here and go back and use another query transformation, connect in parallel to this one, and you apply a where condition saying that where di row id is equal to 2. Right, so you are actually getting 830 records with row id 1 in the first set and 830 records with row id 2 in the second set. Now you do some calculation in like one taxation code or one discount percent in this one and other calculation on this one, and try to load that into two individual tables, and once you run the job you'll see two different outputs, right? Do you get my point, Chandra?
Yes.
Okay, yeah. So that is one case in which you can use this row generation, but not mandatorily required.
So it's like decision tables.
Yes. I don't really link this small transformation with decision, but decision tables on HANA, you're referring to a runtime analysis, right? Runtime, this thing.
Yes.
But this is not something at the runtime. Definitely it is it will allow you to create some structures, and it will allow you to create two sets of your data so that you can apply some business rules on each set, and two or more. It depends on whatever number you pass here.
Like target data tables we can create.
Sorry?
Like we can create target data warehouse tables.
Yes, exactly. Now, if I go ahead and remove this transformation, and if I want to talk about the generate row number function, I think we saw that one already when we are looking at the query transformation. So here, for this column, instead of populating with this, I'll type G in and I will get generate row number. Now this will actually give me an index on the data, like column starting with 1 till the last number of records. If you go and look at this, now you'll see, kill the filters, refresh the data. Now you'll see this in incremental order 1, 2, 3, 4, 5, 6, 7, and it will take you till 830, which is the count of these records. Alright, so this is what is generate row number will do. Sorry? You're talking to me, Chandra?
Yeah.
Mm-hmm.
Can you explain it once again, please?
Sorry, I did not get what you are asking, Chandra.
Can you explain this once again, please?
Once again, okay. I thought you were asking me to wait 1 second. So I was just holding still. Okay, this is generate row number function, which on the same column di row id, I removed the mapping from the row generation transformation, and I'm passing the function. You just need to type gen and it will show you the function. So now what this will do, this will generate a row number for each and every record. I just need to select that, select your job, run the job, and once your job is executed, it will give you an index for all the records starting from 1 till the end of the records in your table. So if you have 1500, it will give you till 1500. If you have 70 records, it will give you till 70. If you have 830 records, it will give you till 830.
Thank you, Rakesh.
Yeah. And the third one, what we'll be looking at is, this is again a function, generate row number by group, and this is done on a particular column. Let us say if you want to identify if there are any duplicate order IDs or repeated order IDs, and you want to do a group by on that particular column, you can drag and drop that column into this function, and right, and once you select your job and run this, so for all the unique order IDs it will give you 1, and if in case if your order ID is repeated, it will give you a value 2, 3, and so on till how many times it is repeated. Right, so let us say if I apply a filter saying that where order ID is not equal to 1 to identify the duplicates. Right, probably in this table there are no records which has order ID which is not equal to 1. We have the entire unique record set that is available. Okay, so this is how you can use these three: generate row number, row generation transformation, and generate row number by group. Right, so just the reason why I'm telling about these three as a combination is there's a possibility that you can get these things in your interview questions to understand how deep you know or is still learning the subject, or if you are I'll just try to confuse you just to make sure that you know it properly. So if you know it properly, then you can answer it properly. That's the intention behind it. And the next one that we'll be looking at is a SQL transformation. Alright, so the definition is very simple. It says performs the indicated SQL query operations which cannot be performed by the built-in transformations. The first thing that you need to understand is whenever you want to utilize the SQL, you need to do something that your built-in transformations cannot do. Right? So if your built-in transformations cannot join two tables, then you can use SQL transformation, which means it will not join definitely tables which don't have a primary and a foreign key relationship, but this is explicitly used when you cannot achieve some logic with your built-in transformations. Right? So let us say if you are very good at coding and you want to write some code. Now if you want to do that in a GUI, definitely you need to pull in some tables and transformations and do a joins and all this stuff. But if you want to do something using coding, so this SQL transformation allows you to write a SQL code here. Right? So first you need to select the data store. So remember, we have three data stores. One is your source target database, and third one is your SAP. So this SQL transformation can identify only your database data stores. right? And the moment you select the data store, it will give you the version and all these things, and you can write your query saying that select star from so I'm just writing a very simple statement here. Click on update, it will update the structure, right? If there is any syntax error, it will not update the structure, it will throw a warning. So just make sure it will check your syntax as well to make sure that you don't end up writing any bad statements. And then you write a complex statement, or you want to join from two different tables and get some output. So this actually will do all the calculations on the backend system itself and get only the result to your target system or to your data services system. So let us say I want to join between two tables using a query transformation. Table A has 1000 records and table B has 2000 records. When I'm practically trying to join these two tables using a query in the where clause with a condition A.field1 is equal to B.field1, then I will end up doing 1000 into 2000 iterations within my system cache. But with this kind of thing, if I'm trying to write a SQL for joining all the tables, so everything is done, calculations are done at the back end, and only those 500 and 600 records, which are an output of your join, will be displayed to your data services system. So this actually helps us to improve the performance, right? And you can also increase the array fit size to make sure your jobs run a bit faster. So then you can further use a combination of transformations, right? You can put a query transformation on top of it to apply some business rules and whatnot. You want to do anything, or you can directly load that into your target table and validate this. Execute your job, and you're not pulling any source table into your data flow, right? So everything is done with the help of the code, and if you want to achieve something with the help of the code, you can use the SQL transformation, right? And all the customer records, 91 records, are pushed onto this table. So this will help you if you are really good at SQL, and if you want to write something, or you're trying to do something using the built-in transformations and it is like not allowing you to do that, or you have to write a complex code to do that thing. To avoid such situations, especially when you're dealing with your source as a database, you can, or your source as any database, not just SQL, any database, you can go ahead and write your SQL transformation in order to get the data from that, right? So that helps you in two different ways. One is you can directly use the code. Second thing is it will improve your performance as well. So that is your SQL transformation. In real-time scenarios, you will be using this, especially when you are trying to do a join between multiple tables and the join operations are pretty complex. You are trying to do a join on multiple columns, and you pretty well know that these tables have a huge volume of data, and you end up getting a lot of performance issues. Then you can go and change that code with a SQL transformation and go ahead and call some SQL help to write a code for you. You can just put in that code in the SQL transformation, execute it, so that your desired activity is done in the backend, and it does a push down actually onto the source system or to the database to which it is connected, and it will get your desired output. All right. So validation validates, or to read it this way, it says routes incoming data based on the validation condition. So to be more clear, this validation works in simple way. So you have a source data set and you want to validate that data. Now you pass it through the validation transformation and it will give you two output tables. One is your valid table and the second one is your invalid table. And this is my source. data, and this is validation transformation, and validation transformation gives tables like valid and invalid. So when you validate your data using this transformation, if it is satisfied, if the condition is satisfied, it goes to the valid. If it is not satisfied, it goes to invalid. So this is how we basically go and validate the data and tell the customers that this is your good data and this is your bad data, and we actually will take a sign off on the bad data saying that okay, these many records got kicked off because this is the reason. So validation transformation actually allows you to capture the bad data, and it allows you to capture one more additional column called as the reason for the failure. So it will not only capture the bad data, but it will also, for each and every record, it will capture why this particular record is a failure. So with that, we can easily, go ahead and, or when we give this data to the data owners, they can even go ahead and look at the data and understand, okay, this is why it failed. So, they can go and correct that, or they can accept why the reason for the failure and consider that is a bad data, and they can give us a sign off, quick sign off on that one, right? So validations are of three major types. You can add any number of validation based on your business logic, but the generic validations that you perform on any project are of three types. One is format, mandatory, and lookup. So when I say a format validation, each and every record has a format, right? So if you look at the SAP table Mara, material number Matner has a format. It is of numeric character length 18. If you look at the customer data, customer KNA1 Spooner is of 10 character length. If you look at the plant information from Marcy, works is of 4 character length. Company code is of 3 character length. So all these particular columns in a table, they are defined with a specific length of the data, which means whenever you are posting data into that, you need to post only that length, right? So that length or a little less than that will be accepted, but if you are trying to post some 20 character length data into a table which is defined with an 18 character length, so what the system will do, it will error out, right? You will not be able to write that particular record into the table. So instead of realizing that after we load the data into the target, it is always good that we validate the data before we load, right? So just to make sure that okay, this is getting kicked off. So instead of the target system kicking off that record, we can actually kick it off even before it goes to the loading part, right? So this actually helps you to load the right data set, and even before you load, you capture the record, those records which will get kicked off, and you give it to the data owner and take a sign off from them saying that these records are invalid and this is the reason what my data services is saying. So do you agree with that? Can you give me a sign off, or you want me to change my logic so that even these records will flow through, right? So one is the length of the data, which is format validation. The second one is the primary key of the data, right? So each and every table that we define will have a primary key constraints, right? So some columns defined as primary keys. So when I say a primary key, there are two basic factors of a primary key. One is the column is not allowed to have any null values, and the second one is the column should not have duplicate values. So these are the two major factors of a primary key column. One is it will not allow null values, and the second one is it will not allow any duplicate records into that column. So this is what we check as a part of our mandatory validation. The third most important validation is a lookup validation. So let us say I'm trying to book my flight tickets from Hyderabad to North Carolina. Alright, so what I will do, I'll log into a portal and I will go and see in my from drop down, I select Hyderabad, and in my true drop down, I select NC. So will this from display something like ABCD or XYZ? I'll definitely not have those sources or destinations, right? Because this has some valid information. So all the froms and tos are captured in a particular table, which is nothing but your lookup table. So if you want to, validate your data, you look at it against the from of this table and say, okay, this is present in this table, then it is a valid entry. If it is not present in this table, then it is a invalid entry. So a very good example on a real time is unit of measure, right? So each and everything that we have has a unit of measure, like your cell phones have a unit of measure, then your cable wires have a unit of measure, the petrol that we buy or the gas that we buy has a unit of measure. So each and everything is measured in different units like liters, millimeters, right? And kilometers and liters, cages, pounds, and everything, each box piece. So there are different ways in which everything can be measured, right? Now, in this unit of measure, there is a T table called T006, I guess, 006, I'm not sure. So there is one T table on SAP which captures all the unit of measures, right? So if the end user enters by mistake, enters something like ABC because he doesn't know the value of the particular unit of measure of that record, and he wants to pass that record into the table somehow, because when he is passing a null, the system is not accepting, right? He'll just pass ABC and the system will take it because it is still a var character of 3-character length. But is that a valid entry or not? You need to cross check with your T table to make sure that it is present in the T table, and or your lookup table or your cross-reference table, you need to make sure that it is present in that. So then you will know that, okay, this is present and this is a valid entry. So this is how you do a lookup validation on the data. If my source data flows in and I need to compare it against some standard list of values to make sure that all these records in this particular column are present in this. A good example is unit of measure. So if all the entries in this table or in this particular column are present on this table, then it is a valid entry. If something is not present in this table, the standard list of values, it is an invalid entry. So we will perform this three kinds of validations on the data generally, but in case you find any other reason you have to validate the data, you can go ahead and validate the data. So for that, I will take the order details table as my source, and I will go to the transformations tab, pick the validation, drag and drop it here, and I'll call it as format, and
Rakesh, format means it will only look for length of the data, or it will also look for data type also.
It's only the length of the data.
Okay.
Right. So initially, when I started data services, there was a big question like, why? Because that time there were no methodologies or no standards set by SAP. So there was a big question like, why I had to run all these three validations in parallel, right? Why can't I run it in sequence, right? So I'll give you a good reason why I'm building it this way, because I was initially part of this discussion or this strategy. Now, if you are trying to do a validation, right, in sequence, right? So instead of having this one here, you connect it after this, and once you connect your validation valid table, or try to connect your transformation to output, so it will give you pass and fail, which means you can only do a validation on the pass records, but you cannot do a validation on the fail records. So let us say I have 1,000 records in my table, but none of the records passed of this validation. So in the subsequent validations, you cannot validate anything else, right? So that is the reason all the data sets should pass through these validations, right? Format, mandatory, and lookup, or whatever the other business rules that you have you have a business specific validations to perform on the data, you can pull your validation transformation, give it that name. Now once you give that name, you should make the transformation work as that name is given, right? So then you go to the validation transformation, and in this transformation you are trying to work on the formats, on the lengths of the data. Now right, so the order ID, let me go and change the table which has some decent data. Alright, it has some columns like ship address, which is 60 character length. Now the source is sending 60 character length, but as per your target system definition it should be 30 character length or less, right? So you need to filter them out even before you load the data. So you can do that validation using this validation transformation. So before we go and see how this validation transformation works, just to give you a heads up, it is divided into 3 regions. One is your schema in, then this one shows your schema out, and if you minimize this one, right, you will see 2 things. One is your validation pass and validation fail. One second, guys. So it will have 2 outputs. One is your validation pass and the second one is your validation fail. So which means when you run this job, it gives you 2 outputs, right? That is why we saw those 2 tags when we tried to connect the valid first transformation to the second. Alright, so now, and in this one there will be 2 additional or 3 additional columns, right? Error action, error column, and row ID. So this will tell, the error action will tell if it is a failure, it will show an indicator as F, and for all the records it will be F. I really don't understand why SAP has to put that in there, because this table captures all the failure records, and definitely all the records will have an F as an entry for that. And then this will tell this record failed on which validation, on which validation did it fail. Like you're trying to do a validation on the ship address, which says that the length of this address should be less than 30 character length, then it will capture that. And you are trying to add more than one validation within, or more than one validation rule within a single validation transformation. All the reasons why a particular record is failed is captured in the error column, and this generates a row ID for all the data. Just go back and open the format validation. Now you want to add a business rule or a validation rule on a column called as ship name. So select the column and click on add. So this is one way, and right, so you can click on add and give the validation rule. Alright, I call this as ship ADRC, and you can give a detailed description here if you require. Then in future, if you don't want this transformation to work or to validate your data, you can just go and uncheck this one. There is no need for you to delete this and save this and rerun your job, change your job flow. You can just uncheck. So this is one beauty of data services. Across the job or across the platform, you get this option where you can uncheck those things that you don't need, right? Rather than deleting them and modifying them or commenting them, you just can uncheck and say that, okay, I don't need this right now, or I don't need these things to validate my data right now. You can just uncheck those whatever it is a rule or a validation or a condition. You can uncheck those things. Right, and second thing, you must have heard about a standard saying on a database is null is never equal to null. You cannot compare two null columns, right? If a column A has null value and you are trying to match it with column B which has a null value, then definitely null is never equal to null, right? So in those cases, if you are trying to do such scenarios, you want to ignore those columns with null values, you can go and say ignore if null, and then there will be some customer specific requirements. Though my record fails, I want this record to go and sit in my pass table, but still it has to be flagged, right? Or though my record fails, I want it to be present in a valid table with a flag, and also I want it to be present in my invalid table, or strictly pass it to the invalid table if it is failed, right? So these are the three options that we can use. So for first one is strictly pass it to invalid fail records invalid table, or pass it to the valid table with some substitution on it, and then send it to both, right? So I'll select this one, then go to the column validation. We are not doing any functions. There's a column validation, and the column name on which we are trying to do a validation is ship address. And in the conditions drop down, if you click on this, you can do all these types of validations. Let us say you are trying to take an order number, it is less than 10,000, or salary less than, if you are trying to find out all this or validate all these records which has a SaaS employees who has salary less than 10,000, then you can give a less than condition and give a value here, right? 10,000. Or you want to do a greater than 10,000, less than or equal to, greater than or equal to, is not equal to, is equal to, is null, not null, like. You can give percentage, right? The ABC and percentage, saying that if it has this word in that one, you identify this. Or you can define a range between 1 and 100. So the screen differs on whatever the option that you select, right? Match pattern. So this is one of the most important thing that we need to know, and also that is one of the most important validation that we perform on the data, right? So let us say I have an employee number. So this is the standard format of an employee number, right? It can be EMP1 2 3 4 5 or 1 0 0 0 0 0. Then the next employee is EMP1 0 0 0 0 0 1 and 2 and 3 and so on. Like this is my standard employee pattern. So which is a combination of characters and numerics. So characters are identified by X, and if in case you have first as capital and second and third letters are small, so you can identify them capitals as capital X and small as small x, and all the numerics are represented by nines. So this is the pattern of this employee number, right? E, capital X, and small m and p, X and X, and all the numerics, the number of numerics that you have, you will be identifying them with 9. So this is a pattern, match pattern. You say that, okay, this is the pattern in which this data should be. If it is not in this pattern, then capture that. So in US, your social security numbers will have a pattern like 4 digits and then 2 digits and then 3 digits, right? So you define a pattern saying that if you are validating any column with that kind of data, it should be present like that, right? And telephone numbers, if you are getting telephone number as an input, and it should be 10 character length, right? If its pattern should be 99999. It cannot be an alphanumeric. So you have to pass 10 nines here. So that is a match pattern that you do on the data. Now inset. So let us say if I am trying to search for something in this set, I'll give 10, 20, 30, 40. So if you can process your entire input data on this set. So remember, each and every value should be in single quotes, and they are separated by comma and open and closing brackets. Right, so your data should be present in this one. So if you are validating, saying that if it is in this set, it is a valid entry. If it is not in this set, then absolutely it is an invalid entry. Right, so exists in the table, we look it for at a lookup, and this is custom condition. This is where we do your format validation. So this is where we are getting to, but since we have multiple options ahead, I'm trying to talk about that. Now here you can write your custom condition saying that length of my orders table dot ship address. You just need to type the table name. It will display like the way it displays in your Oracle. Is less than or equal to 30. So that is my condition. The length of this ship address should be less than or equal to 30. It should not be beyond 30. So that is one validation. And if I am now I'm sending it to fail, right? So if you look at the bottom section, it says that if any rule fails and you are trying to send it to pass, substitute that with some value, right? So if I am trying to send it to pass here, which means I'm not capturing that in invalid table, then you can enable this, and for that column ship address, you give an expression like question marks, so that in your target system, when you go and look at the data, so though it is not present in this or its pattern is wrong, instead of kicking it off, it will load that record with a question marks on that one. So you go and select write statement, select star from the target table, and wherever you see a question mark, you pretty much understand, okay, this is my bad data and that is the reason why it is failed. Or you can keep a flag on that record saying that it is a failure record, right? So this is an additional option that you see here, send it to pass and send it to fail. Generally you keep it to fail. And you also have an additional tab here called as collect validation statistics. So if you're trying to run a job, schedule a job on a daily basis or a weekly basis, right, your system has an ability to collect the statistics of your data, so that next time you run it, it will go and utilize those stats and try to run it a bit faster. And you can collect some sample data by checking this box. Alright, you can go and add one more rule or edit an existing rule or delete the existing rule, or even delete these conditions that you are passing. Alright, so this is your format validation that you do on your length of the data. Alright, so that is one important validation. The second one is a mandatory validation. So let us say orders ID is my primary key, and on this order ID I am doing a mandatory validation, and in this mandatory validation I don't want it to be null. So what I'll do, I'll say is not null, right? So that's the validation. And the third one is a lookup validation. So lookup, you need to cross-refer to some other table which is present on your data services data stores, which means it should be a permanent table. So you cannot look up onto a template table. You can only look up onto a permanent table. So you need to convert your template table to a permanent table if in case you are planning to do a lookup on that. So go to the lookup validation. So let us say if my order ID in the orders table is present in the order detail table, then it is a valid entry. If not, it is an invalid entry, right? So go and add, give the rule name, description, and then go to the column validation, say order ID, and you need to select existing in the table. Which table? It is present in your source data store, and the table name is order details. Click on OK, and the column on which you are trying to do a comparison is order ID, which means the orders.order ID is equal to order details dot order ID. So if it is present in that table, then it is a valid entry. If it is not present, then you need to send it to fail. Right. So these are the three validations, standard validations. Go and look at any SAP projects or non-SAP projects. We will do these three standard validations in one of our recent pharma company project. So we had to add 14 or 17 validation rules to validate the employee data, because that depends on the customer specific thing. But if the customer is not having any validations, you better suggest these three validations to the customers so that they will have a standard data set loading into the target. Now, a target table can take or feed from only one transformation, which means I can only pass from this, and I cannot pass from 2 or 3 different sources, right? So how I'm going to put this into a valid table and an invalid table? So any ideas how we are going to put that into an invalid and valid table? How I'm going to combine all this valids into one set and invalids into one set and push it? So we saw this transformation called as merge. So we will use it as a combination here. I'll call this as merge val, and the second one as merge inval or inv. Now what I will do is, merge can take multiple inputs, right? The reason or the condition for merge is whatever is feeding it from the source should have the same metadata. Alright, so and I will go and merge this, all the fails together. Now I can connect this directly to the table, right? So I can merge all the failures and load that into the invalid table, and I would like to use a query distinct here. Before I load it into my valid table, I would like to use a query distinct. Any guess why I want to use a query distinct? I'll go and select distinct rows here. Okay, the reason why I'm using it for this one is, let us say record 1, which is order ID 10248, is valid here, right? The format it passed, so it goes to this valid table, and again it validates the mandatory part as well because it is not null. It goes here and it satisfies the lookup part as well, so it is a pass, and then it goes to the target table. So in the valid table I end up having 3 duplicate records. So though the same record is validated multiple times and it's passed multiple times, but I don't need duplicate records to be present in my valid table. So that is the reason why I will use a select distinct to ignore the duplicates and pass only one unique record to my valid table. Then why I'm not having it for invalid, right? So the reason why I'm not having it for invalid is the same record 10248 can fail for this, can fail for this, and can fail for this too. Which means if I just select distinct records here, and if I probably it will capture only the first invalid record. So I go and fix it on the data, then again it will fail for the second validation, and if I go and fix it, it will again fail for the third validation. So on the invalid part, I want to understand all the possible reasons why a record has failed, because I can go and fix it at one time, right? So your validation is done. Now select your job and execute it. Right? Validation is done successfully. Now go and look at your valid table. Right? It has these many records which are valid. And you go and look into your invalid table. So it has some 37 records which are invalid. And you go and look at the reason. It will tell you the reason failed for this rule is ship address. So it was not able to satisfy the ship address, and if you want to cross check this one, right click and say copy cell. It's just for you to do a quick validation. Paste it here and then write a function is equal to a length of b2. Right, it is 42, and the condition that we gave is it should not be greater than 30, and that is the reason why it failed. Right, you can do a quick cross check on your data. Right, so these are the 37 records which could not satisfy the address condition, and remaining validations are right. None of the records failed on the any other validations, only the address validation, the format validation captured these 37 records out of all the source records that we have. Right, so these are the standard validations that you perform on your data, but yeah, as your customer requires or as your project demands, you can go ahead and add your validations on your job. Right, we have seen all the different types of validations that we can do. Using the validation transformation, we have these options. You want to modify this, double click on this and go to this drop down. You have all these conditions in which you can go and validate the data. Alright, so this is how we can use the validation transformations in our yeah.
ఇక్కడ మనం నావిగేషన్ స్ట్రైట్ లైన్ రావడానికి మీరు ఏదో సెట్టింగ్ చేశారు కదా, అది ఒకసారి చూపిస్తాను.
Yeah, tools, options, designer, graphics, and this is where you can choose it to be a curved line, straight line, or straight line with vertical and horizontal edges.
Okay. Thank you.
Okay, yeah. Alright, so yeah, that's it from my end today. If you have any questions, you can go ahead and ask your questions. Today we saw about row generation, generate row number by group, and SQL transformations along with validation, and we understood what are the different types of standard validations that we perform on the data. Alright, so tomorrow we'll start looking at XML, then we'll try to read the nested structures tomorrow, and we have XML map, and as I told you, query transformation is hero of transformation, so we will see how we can handle the nested structures using query transformation as well. Okay, so we'll start with these things tomorrow, but if you have any questions, you can go ahead and ask your questions now.
So we can add any number of validations?
You can. There is no restriction.
Okay.
Yeah.
Rakesh, in SQL transformation, we can use any kind of metadata like views or anything? Stored procedures, views?
Yeah, you can call views and you can call tables, but you can execute a stored procedure from this one too.
I see. Okay. So is there any limitations, like we can use any kind of limitations on top of it, the code?
No. We don't have any technical limitations here. We can go ahead and write as much as complex statement, that, and you can also do a push down onto that one, onto the source system, and you can just get the output required.
Okay.
Mm-hmm.
I'm not sure this is a valid question or not, but
No, go ahead.
Generate row number,
Mm-hmm.
something I mean, when can we use it? Like in real time, when we are pumping the data to the like the facts and dimension tables during that time, consolidate the tables and add this generate row number on top of it, or is it like surrogate key kind of? Or?
Yes. So we also have a key generation transformation. We'll look at that a little later. Alright, so which will generate a surrogate key. But yeah, so you can use a generate row number function to create an index kind of things on the data, so that if you want to sort the data and send it out, so you can use this one and sort out this one, because automatically it gets generated on that or sorted on that particular row generation column that we use. And if you want to see how many records are there, so you can just do that, or if you just like an indexing on the data. But if you are asking about row generation, this is in typical real-time scenarios when you don't have a structure and you want to build it, right? Or when you don't have a source, still you want to call it with the help of a function or some other structure. You just want to copy some structure from somewhere, but still you don't have a source for it, so you can use this row generation. We have good examples going forward to see the row generation. I think that will clarify most of your questions on row generation.
Rakesh, can we do indexing using bots?
See, indexing, when you talk about a specific indexing or a database terminology, so it is like on a particular column or a combination of columns, you go and create an index, and those indexes are of type numeric or images, right? So those are database specific properties which you have to do it on the database, not on the ETL. So ETL does an extraction, transformation, and loading, but once you load into the target table, then you can go log into the database and do those indexing on the database. Data services, just as a reference on the front end side, you can create some row generation columns, right, for you to refer it as an index, but technical backend database index, you cannot create it using data services.
Thank you.
But there is still a window that you can go and create some DMLs, like create table statements, or if you want to use it in a complex manner and you want to do a lot of R&D on that and achieve it, yeah, definitely you can do that. Because today, one live example I can talk about today is I'm trying to do a lookup on this one, and this error column that we are capturing in the invalid table, it has the column name on which this record is failing, right? It's saying me the ship address, but if you look at the rule, right, so my rule name is not ship address, it is lookup. So the customer wants to see output or the failure reason as lookup, but not as a ship address. So I had to break through the logic and try to rebuild another flow and show it to the customer, like this is how you get the lookup as a validation failure rule, rather than displaying the column. So that goes through a long process. Nothing is impossible with data services, as I say, right? You can go ahead and build it. It is not just a limited tool. You can do whatnot. You can do everything using data services, provided we know how to use it. And you also should understand that, is this a right way, writing or doing a big data flow and achieving one small task as an output? So is that recommended? Because I did that to satisfy my customer today, but again I told him that this is running for 600 seconds, so definitely I don't think you will appreciate this one. Because I delivered his output and then I contradicted his thought, saying that this is wasting 600 seconds of your job execution time just to show the rule name instead of column name, and I don't think you need it. So then he immediately said, like, it's okay, I can go and refer to an Excel when there is a column name, and he went back to that one. So yeah, you can do everything using data services. You just need to do a lot of R&D on that. That's it. Alright guys, I guess like everybody's got their system access and they're doing a practice. Unfortunately, I could not log into your systems to see what you're practicing, but yeah, I guess you guys are practicing. I got a few questions. So yeah, keep practicing. and take care and see you in the next session. Bye for now.